In this video, we will focus on Chapter 3, Application of Differentiation. So before we start our lesson today, you need to memorize those formula for area and volume, for cone, cylinder, for cube, cylinder, cone, and sphere. So you have to remember the area and volume for each of the shape. So next, we move on to the related rate. So in example 1, so you can see that in our example 1, a block of ice in the shape of cube. So the shape is cube. So first, let's say I try to highlight. So the shape is cube, originally having of 100 cm cube. So the volume is 100 cm cube. It's melting. So another keyword here is, let's say, another keyword here is melting. So it's melting in such a way that the length of each of its edge decreasing. Again, we have the words of decreasing at the rate of 2 cm per hour. At what rate is its surface area? Next is the surface area. Decreasing at the time its volume is 64 cm cube. Assume that the block of ice maintains its cubical shapes. So next, let's say we look at this question. So first, you have to remember that our ice, the block of ice is in the shape of cube. So let's say here is the cube, for example. Let's say roughly to graph this one. So here is the cube. Let's say I assume that the edge is x. So we have the x. So again, the cube is melting in such a way that the length of each of its edge, the edge is decreasing. So means that since our edge is x, so means that dx over dt will be equals to negative 2 cm per hour. Why is negative 2? Because of the words of decreasing at the rate of 2 cm per hours. So hours, let's say hours. At what rate is its surface area? So surface area is dA over dt is equals to, this one we need to find the dA dt, decreasing at the time when the volume is 64. So when the volume is equals to 64 cm cube. Okay, first step, we start from this question, which is dA over dt. So dA over dt, what I'm going to do here is I try to separate it into two different related rate. So here is our dA, here is our dt. I will separate into two parts. So what we're going to substitute here? So let's say I move on, dA over dt will be equal to, let's say again is dA, here multiply with dt. So what I'm going to substitute here, I will refer to the information that I have. So what I have is dx over dt. So means that here I should substitute with dx. Here is dx. So in this case, dx over dt is equals to negative 2. So now I just have to concentrate on this part. I try to find the dA over dx. Differentiate A with respect to x. So differentiate A means that is the area. So next, what is the area for the cube? So this is, let's say, cube. The area for the cube is equal to 6x squared. You can refer to the previous slide. Area of the cube is 6x squared. Next, I'm going to differentiate dA over dx. differentiate A, oh sorry, dA over dx, differentiate A. So differentiate A with respect to x is equals to 12x. So next I will substitute in this reiterate. So next step, dA over dt is equals to, by referring to here, let's say I change to color. So by referring to this part, so dA over dt is equals to dA over dx, which is equals to 12x. So it's equals to 12x. Multiply by dx over dt. Our dx over dt is negative 2. So multiply with negative 2. So 12x times negative 2 will become negative 24x. So when, next step, when volume is equals to 64 cm cube. So when volume is equals to 64, I just write 64, let's say cm cube. Now we're going to substitute the value of x. What is the value of x? Again, volume for the cube is x cube is equals to 64. Why is x cube? X cube because the volume for the cube is x power of 3. So x is equals to the third root of 64. Means that I try to move power of 3 to here. So it's the third root of 64. And the third root of 64 will be equals to 4. So finally, our dA over dt, or I can write here, therefore, our dA over dt is equals to negative 24 multiplied by x. Our x is 4. So 4 times negative 24 will be equals to negative 36. Since this is area, so the unit suppose is cm squared per hours. So this is the answer.